In this video, we are going to go over how to find the greatest common factor of a polynomial, as well as how to then factor out that greatest common factor. That greatest common factor, also known as the GCF. So what might be worth your while would be to review, in one of my earlier videos, how to find the greatest common factor of two terms involving variables. We weren't calling them monomials then, but we are now. So let's do it. So step one says find the GCF. Essentially, the GCF is a review of where we've been. You're finding the monomial that goes into both of the terms in the polynomial. Okay, so what's an easier way of saying that? Well, look at the coefficients first, and we say, what is the highest number that goes into both of them evenly? Well, this is a 6 and there's a 1 there, so the highest value that goes into both coefficients is 1. Okay, so that's the greatest common factor, I guess. I won't even write that down, of the coefficients. Then you look at the variables and you say, what is the highest power of those variables that goes into each of them evenly? The highest power that goes into both x cubed and x squared? X squared goes into both of those evenly, right? Another way of thinking about that would be, what is the lowest power that goes into, well, that is here, that is available, right? So the lowest power out of the two of these is the biggest power that will go into both terms. There you have it, x squared. And again, if you need a why behind this, check out my earlier video on finding greatest common factor. So now that we have the GCF, we'll go back to that shortly of how to factor it out. We're just going to go through each of these and find the GCFs. So in letter B, the GCF of the coefficient is the greatest number that goes in 5, 10, and 15, or 5, negative 10, and 15. That would be 5. So 5 is the greatest common factor of the coefficients. And then what is the highest power that goes into a to the third, a to the second, and a? Well, a is the highest power that goes into itself, a squared and a cubed. So 5a is the GCF. There you have it. So we're not factoring the GCF yet, we're just finding the GCF. Into C, 4g to the 8th, 6g to the 5th, and negative 10g to the 3rd. The highest factor, the largest number that goes into 4, 6, and 10 evenly? 2. So that would be the greatest coefficient that goes into all those numbers. Now g to the 8th, g to the 5th, and g to the 3rd, the highest power that goes into all three of those would be g to the 3rd, right? We can't have anything higher than a third power because it won't go into g to the 3rd evenly. Nice. And last but not least, a very challenging problem. We're going to find the greatest common factor of this thing right here. We'll start with the coefficients. We have 7, negative 21, and negative 14. The highest factor, or the greatest number that goes into 7, 21, and 14? 7. 7 goes into all of them evenly. And now let's look at each variable individually. As weird as it looks, because every monomial has two variables in it, we'll just go variable by variable. In terms of the x terms, we have x to the 3rd, x squared, and x squared. So the highest power that goes into x to the 3rd, x to the 2nd, and x to the 2nd? X to the 2nd. That is the highest power that goes into all the x terms, and we'll keep building it. How about the w's? We have w to the 1st, w squared, and w to the 1st. So w to the 1st is the highest power that goes into all of them. So your GCF is 7x squared times w. Nice. So that's how to find the greatest common factor. Now we're going to figure out how to factor out the greatest common factor. And another way of saying that, we'll start with A, is what times x squared will get us back here. It's like you are undistributing. Some teachers describe this as dividing each term by your greatest common factor, and that's correct as well. I like to think of it as undistributing. So you're saying, what times x squared will get us back to 6x to the 3rd minus x squared? So literally you're saying x squared times what gives you 6x cubed? Well, 6x times x squared, you distribute to check your answer, gives me 6x cubed. So I know that 6x is the first term. I've got a minus sign. Then you're saying, what times x squared gives me x squared? Well, x squared times 1. And again, you can check your answer by saying x squared times 6x is 6x to the 3rd. X squared times minus 1 is minus x squared. Nice. All right, let's go on to B. So in B, again, we're going to undistribute, right, or factor out 5a. So we're saying 5a times what is going to get me back here? Well, 5 times what gives me 5? That's just 1. And then a times what gives me a to the third? A squared. 5a times a squared, sure enough, gives me 5a cubed. And again, I like to check as I go through my work by multiplying this out and seeing that I get back the original terms in my problem. 5 times what gives me negative 10? Well, that would be negative 2. And a times what gives me a squared? A times a. And sure enough, 5a times 2a, negative 2a, gives me negative 10a squared. Last but not least, what times 5 gives me 15? Positive 3. 5a times 3 does give me 15a because, well, a times nothing, well, a times 1 gets me back to the a term. So that's why I have no a there. Beautiful. Guys, what we're really doing here is we're factoring like you've always done, right? I'll give you an example. If you find that the greatest common factor between, let's say, 20 and 40 is 20, then you're really saying 20 times 1 gives me 20, and 20 times 2 gives me 40. That's how we know that 20 is the greatest common factor, because the remaining bits have no common factors among them. So all we're really doing is the same thing, but with variables now. We're saying what times this greatest common factor gets us back to the original numbers. In this case, the numbers involve some variables. Let's keep rocking and rolling. It's a longer video, but we're covering a lot of ground. I love it. Let's keep the momentum. So here the greatest common factor was 2g to the third. So that's what we're going to factor out. So you take your greatest common factor and you say, what times 2 gave me 4? Well, that would be 2. And what times g to the third gives me g to the 8th? Well, g to the 5th. And we know that because same base, add the exponents, gets us back to g to the 8th. This checks out. Plus, what times 2 gives me 6? 3. And then g to the third times what gives me g to the 5th? Well, that would be g to the 2nd, again, because we'd be adding the exponents 2 plus 3 to get me back to 5. And finally, minus, because 2 times something gives me a negative, 5 would get me negative 10, and it's just 5 because 2g cubed times negative 5 gives me negative 10g cubed. So again, checking your answer by distributing, because what we're doing is we're factoring, which is the reverse of multiplication. It's like we're dividing out that term. This nasty one gave us the GCF of 7x squared w, so that's our GCF, 7x squared dubs, times. Well, what times 7 gives us 7? It's just 1, so I'm not going to write that down. What times x squared gives me x cubed? X. And that's it, because 7x squared times x gives me 7x cubed. There's a w there, which when I multiply by the 1 that's there, will give me back w. So we're done with that term. Minus 7 times 3 is going to give me 21. So we'll have a 3. What times x squared gives me x squared? 1. So there's nothing I have to put here as far as an x term goes. What times w gives me w squared? W. 7x squared times 3 gives me negative 21x squared. W times w gives me w squared. Sweet! Minus again. 7 times 2 will give me 14. So there's going to be a 2 here. X squared times 1 is going to give me x squared, so I don't need another x value to get to x squared. W times 1 will give me w. So again, I don't need a w value. And that's it. Folks, the name of the game here is breaking down mentally each part of the greatest common factor when you factor things out. For instance, we factored out a 2g cubed here. We were only considering 2 times what gives us 4, and then our brain shifts to g to the third times what gives me g to the 8th. Rather than doing all the pieces at once, if you can break each of these problems down into smaller parts, you will find success much quicker. And after a little bit of time, you'll get to these answers mentally. And we'll get there. But until then, master it and just observe how sweet it is.